Okay, section 6.1, we're going to talk about slope fields, and we had discussed these earlier in the year, I believe in chapter 4. And what a slope field is, it's a two-dimensional plot of the visualization of the graphs of the solutions to the differential equation, which is, again, kind of wordy. But basically what it's saying is if you have the differential equation, dy over dx equals 2x plus 3. That's called a differential equation, which is just, notation for the derivative of some original function. Well, the slope field that's on your notes basically gives the visual representation of what the actual function would look like, and what those little dashes are. They represent down here the slope of the solution to the curve at whatever point that's at. And we'll talk, I'm not going to read through all these directions, but I'll just show you basically what's happening here. So the graph of the little piece of a straight line centered on the lattice point, and that's just like that little ordered pair dot there, is the slope that you've calculated. And again, what that straight line represents is the tangent line to the solution of that curve. All right, so let's just go through and do one of these. Okay, so here's our differential equation, y prime is equal to x, which is, again, really dy dx is equal to x. And what this slope field over here represents is all these small dashed lines here are just slopes to the original function at that point. And these solid lines are just certain particular solutions. So the slope field to the left here gives you 3 particular solutions to this differential equation. Now, when you integrate, and that's what we're going to do eventually, we're going to integrate this differential equation to come up with the original function. Actually, we're not going to do that until later, but when we integrated something, we put a plus c at the end of it. Well, depending on what that c value is which one of these graphs, these particular functions, is going to be. Okay, so hopefully that made some sense, and I think as we go through and do a couple of these, it should make sense in your head. So here we're going to create now the slope fields for this following, and remember, this is a differential equation. Okay, so the first thing I'm going to do is I'm going to write it as dy dx is equal to x. And what we're actually going to do for each one of these dots, for each ordered pair, we're going to find the slope at those points. And again, how are we going to find the slope? Well, we're going to plug it into here because the differential equation gives you the derivative, and if we plug in a point, we're going to figure out the slope. Now, this one's kind of a little bit easier because it's only the right-hand side's only in terms of x. Sometimes it'll be in terms of y, sometimes it'll be in terms of x and y. So what we're going to do is we're actually going to make a table of values. We're going to choose x values, we're going to choose y values, we're going to plug it into the differential, the dy dx, to find out what the slope is at that particular point. All right, so let's start off with, we'll choose the point 0, 0 here. So the point 0, 0, if we plug it into this function, well, there's no y value for this function over here, there's just an x value. So if I plug in 0 there, I'm going to get 0. So that's the slope at that point. And what you do for a slope field is, the slope is 0, so it's a horizontal line at the point 0, 0, and we're just going to put a small dashed line that's horizontal to represent the slope is equal to 0. Now we're going to keep picking points, and as you get better at this, you're going to see how you can save yourself some time, because I know for every single value of x that I choose is 0, and it doesn't matter what y is going to be, my slope's going to be 0. So if I choose the point 0, 1, which is right here, I'm going to plug it into my differential equation, meaning I'm just going to plug in 0 in for x, that's the only thing that's there, and my slope is going to be 0 again. So now I put another horizontal line here, just a small dashed line to represent what the slope would be. Now anything I choose for 0, 2, 0, -1, anything with 0, my slope is going to be 0. So I can just go right along the y-axis here and put my slope's going to be 0 for every single one of these points. Now hopefully you can see this can get a little bit tedious because look at all the points I have to choose for this to sketch this slope field. So let's try another point. Let's try the point 1, 0. Well, the slope at 1, 0, if I plug in 1 into x, there's no y value again, my slope is 1. So now you have to sketch a line where the slope appears to be 1, and you have to visualize the slope being like this, because I would go up 1 over 1, and it looks like it's about 1. Well, any value where x is 1, so if I choose 1, 1 for this, again, plugging this point back into here, I'm going to get my slope as 1. So all of the values where x is 1, which is all of these vertical along this column, I guess I'll say, all have a slope of 1. And you're estimating about what a slope of 1 looks like. All right, again, hopefully you can start to see what's going to happen here. So if I plug in 2, 0, we'll say, well, 2, 0 is this point here. If I plug it into the differential equation, my slope's 2. So it's a little bit steeper than the ones that are here. So now it's a little bit steeper. So I got to imagine going up 2 over 1. So it's going to look like this. And all the ones that are along that column are going to have the same slope. So all of these are going to have the same slope, which is 2. Now again, the ones here have to have a steeper slope than the ones here. And they just need to look steeper. All right, because it's a sketch. Let me erase that. Okay, so let's make this go a little bit quicker here. Now if I go to 3, well, 3, 0, my slopes are going to be 3, so it's even steeper. So these are all going to be 3 along here. And these are all going to be 3, 3, and 3. All right, well, we haven't taken care of some points on my other side of my graph. So let's choose the point -1, 0. Well, if I put in -1 for x into my differential equation, my slope's -1. So now on this side, my slopes are all negative, and they go this way. And again, anything with an x-coordinate of -1, in this case, is going to have a slope of -1. So I can quickly go down this column and sketch in what appears to be a slope of -1. All right, I'm not going to plot the points in my chart, but at -2, -2, 0, or anywhere there's an x-coordinate of -2, my slope's going to be -2, so it's a little bit steeper negative slope. Look like this. That one's a little bit too steep, but get the idea. And at -3, they'd be even steeper, right? Okay, so that represents my slope field for that differential equation. Now, I'm just going to show you, this is what we do in section 6.3, a little bit more difficult than this, but if we took dy dx is equal to x as my differential, and I want to solve that differential, if you remember back when we did this in section, I think it was 4.4, you move the dx over to the other side, and you integrate. Well, the integral of dy is just y. The integral of x is x squared over 2 plus c. And what this slope field represents, all of these slopes, represent all the possibilities of that function x squared, right? It's a parabola. So if you look, if you pick any point, you can sketch a parabola through this. You know, if you pick the point 0, 0, there'd be some parabola that would look something like this. So the original function is some parabola, and these represent all the slopes. That one's a little bit off, but again, it's just a sketch of all the possible tangent lines to a point. And that's what a slope field is, and that's how you do it. They get a little bit more complicated, but that's the basic idea. Okay, I'll talk about this later. This just basically, if you're given a slope field, how do you match it up with its corresponding function or differential? I'll show you how to do that for some homework problems. Oh, one other thing I wanted to mention about this. If you have a differential equation, in this case dy dx is equal to x, and the right-hand side is all in terms of x, so all in terms of x, the columns will have the same slope. meaning this: all of the values, or excuse me, all of the slopes in this column will be the same. All of the slopes in that column will all be the same. So if it's in terms of x, once you get one of these, you can get them all real quickly. So you can see all along these columns we have our same slope everywhere. Okay. Now when you do the next one, which is in terms of y, instead of the columns all being the same slope, the rows will have all the same slope. But we'll show you how to do this. So you go dy, let me change colors. So dy dx is equal to y is my differential equation. So I'm going to do the same thing. I'm going to make a chart, pick x values, pick y values, and plug it into my differential dy dx and come up with the slope. So we'll try 0, 0 again. Well, the x value doesn't matter because there's only y values. I plug in 0, I get 0. So that means my slopes here at 0 is going to be a horizontal line. So I sketch a horizontal line because that's where the slope is 0. Now again, all of my y coordinates where they're going to be 0, whether it's 1, 0, negative 1, 0, 2, 0, because there's no x value here, these are all going to be 0. So now I can go all along this row and show that my slopes are all 0. Okay, and you just got to keep picking points. So let's try the point, let's try 0, 1. Well, if I do 0, 1 and plug it into my differential, my slope's going to be 1. So my slope here at 0, 1 is 1. Well, everything along that row is also going to have a slope of 1. And I'll just pick one like 1, 1. This value is insignificant, so the y values. So these are all 1. And again, you can get pretty good at these going quickly. Now, if we go down to 0, negative 1, these are all going to be negative down here. So negative slopes are going to go this way. And again, this first section, we're just sketching what slope fields are. We'll kind of put it all together by the time we're done section 6.3. All right, let me keep going here. So if I choose the point 0, 2, my slopes are all going to be 2. So a little bit steeper here. Steeper, steeper, steeper. Positive 2, positive 2, positive 2. And these are going to all be negative. All right, 0, negative 2, a little bit steeper. Okay. And then negative 3 and positive 3 would be even steeper than that, so go like this. And these would be negative steeper. And I should probably be using a straight edge to make it perfect, but that's what your slope field would look like. Okay? All right, now let's do one more where there's an x and a y. All right, so we're going to rewrite this. This takes a little bit more work, but it's the same idea. dy dx equals x minus y. Okay, we're going to choose x values, we're going to choose y values, we're going to plug them into our differential, which is dy dx, and come up with points here. So I always try 0, 0 first. Well, if I plug in 0, I'm going to have 0 minus 0, which is 0, so my slope here is 0 again. That's not always going to be the case, but it has been for these three. All right, let's pick the ordered pair 0, 1. Well, if I do 0, 1, it's going to be 0 minus 1, so my slope is negative 1. So at the point 0, 1, my slope's negative 1, so it goes like this. Okay, at 0, 2, my slope's going to be 0 minus 2. And again, I'm plugging it into here. It's going to be negative 2. So this slope's negative 2, a little bit steeper. Here it'd be negative 3. All right, let's try something else. Let's try 1, 1. At 1, 1, I'm doing 1 minus 1, so my slope is 0. So at this point here, it's 0. Hopefully you make the quick connection between whatever the x value is the same as the y value. For this particular differential equation, 2, 2, my slope is going to be 0. So that's going to be 0. 3, 3 is going to be 0. If I do, what happens if I do negative 1, negative 1? I get negative 1 minus a negative 1. So it's 0. So all of these diagonals will be the same. Now watch what happens when I do 1, 2. 1, 2. 1, 2 is 1 minus 2. My slope is negative 1. So now all of these diagonals going this way are going to be the same slope of negative 1. And hopefully you can realize that these are all going to be the same diagonally this way of negative 2. And just if you don't trust yourself, pick a point. Let's pick this point right here of negative 3, negative 1. If I do negative 3 plus a negative 1, excuse me, minus a negative 1 plus, equals -2. And as I said, all of these slopes are -2. These will all be -3, so they're even steeper. And you just go diagonally across. All right, let's get an idea of what the other side's going to look like. So let's pick a point 2, 1. Well, if I do 2, 1, that is going to be 2 minus 1, which is going to be 1, so my slope's +1. At 2, 1, my slope's +1. So it goes like this. At 3, so all along here, they should be +1. All right, let's try the point 3, 2. 3, 2, this would be 3 minus 2, which is 1. So this is all going to be 1. Wait a minute. I picked the wrong point here. I wanted to pick 3, 1 to represent this point right here. So 3 minus 1 is 2, so that slope is going to be 2, so it's a little bit steeper. This is going to be a little bit steeper. Again, all along the diagonal here, they're going to be a little bit steeper. The next one at 3, 0, 3, 0 is going to be 3 minus 0, which is 3. The slope is 3, so a little bit steeper. Okay, and you keep going, and that's that slope field. Okay, let's see what we have next. I'll do this last one here. I don't know if there's any more. I'll do this last one. So dy dx is equal to x over y. Make a chart, x, y, plug it into your differential to get the slope. I'll choose 0, 0. Well, if I plug in 0, 0, I get 0 divided by 0, which is undefined. So anything with a y coordinate of 0, which is all of these values across here, is going to be undefined. There's no slope there. Do not put anything at any of these points where the y coordinate is 0. Okay? Let's try the point 0, 1. Well, if I put 0, 1, it's 0 divided by 1, which is 0. If I do 0, 2, it's 0 divided by 2, which is 0. So where my x coordinates, these are all going to have slopes of 0, which are horizontal lines, horizontal line. Do not put one at 0, 0. Okay, let's do some other points here. How about 1, 1? Well, if I do 1, 1, it's 1 over 1, and my slope's 1. So right here at 1, 1, it's 1. At 2, 2, it would be 1. At 3, 3, it would be 1. All right, you might want to do another one here. How about 1, 2? Well, the slope at 1, 2 is a half. Now this one you got to be careful of. It's up 1 over 2, so it's not as steep. At 2, 3, it's 2/3, right? It's 2 over 3, so it's 2/3. So again, it's less steep than that. All right, let me go over to the other side here. How about -1, +1? Well, I get -1 over 1, which is a -1 slope. So this slope right here is going to be -1. All right, and I'm going to keep picking points here. I'm not going to do all these, but you're going to get the general sense. I'll pick one in the first quadrant, pick one in the second, one in the third, one in the fourth, so you can get an idea, and I'm not going to, again, plot all the points. But if I choose -1, 2, I get -1 over 2, so my slope's -1/2. So at the ordered pair -1, 2, my slope's -1/2, which is less steep than the one that's below it. Let me try a third quadrant point, which is -1, -1. And that ends up being -1 over -1, which is 1. So my slope here is +1. And it goes like this. -1, -2 would be +1/2 of a slope, so it's not as steep, so +1/2. All right, let me try another one in the fourth quadrant, which is 1, -1. Again, my slope's going to be -1 on this side, so -1. This one would be -1/2. Now again, you'd have to fill in all these points. Usually on the AP exam, they just make it, go by a 2 by 2 all the way around, so you don't have to do so many. So that's the slope field for that if I continued all the rest of the points. And actually, let me just cheat a little bit. I'll look at my notes here. And then put all the other slopes in for this. So these go a little bit less steep like this. It's going to be like this. These on this side, steep. A little bit steeper. Like this, like this. And again, I'll do a couple over here. This is that, flatter, like that. And steep, flatter, flatter. Okay, and you get an idea what it is. But again, there's nothing along the x-axis there. Okay, that's the end of section 6.1. Next time we meet, if you have any questions, just ask. And that's that. All right, thank you.